Hi everybody, it is Mr. Ransomer, and today this lesson is about what can we do with our nested for loops. We started talking about these things last week and earlier this week. A for loop, of course, is just a definite loop. If you want to go 1 to 10, for loop 1 to 10. Again, we learned about nested for loops already, so if you want to do a loop inside of a loop, we call that a nested for loop. But what can we actually do with those things? So let me show you. First, let's make something like a multiplication table. So we'll go, let's say 10 by 10. Sounds good to me. Sounds good to you. So the way I like to program these, I don't like to use row and column, and I probably mentioned this in class already simply because people get row and column mixed up. So I tend to use the variables v and h for vertical and horizontal. The v loop is the outer loop. It stands for the number up and down. So they are rows, but I like to do it just v for vertical. I'm going to do in range of 11. And remember, range of 11 means 0 to 10. Do we want 0 in our multiplication table? Probably not, because 0 times anything is 0. So let's do 1 to 11, hence 1 to 10. Inside here, I'm going to do for h in the range of 1 to 11. And then I'm going to print the product of the vertical and horizontal, the row and the column. So print v times h. And then I want to print left to right because the inner loop prints left to right. If you think about it, when you type, enter, you go to the next line down. So you go left to right, at the end of it, you hit enter to go to the next line down. So I'm going to do what we've done in the past here. Once the end character is quote, quote, meaning nothing. If we need to modify that, we will. And then at the end of it, at the end of that line, remember this represents one line left to right. At the end of that, I'm going to say print by itself, because that's what makes it go to the next line down. And so this little tiny stub of a program, nested for loops, this is going to give me this, which looks really ugly because everything's crammed together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 2, 4, 6. It's just really hard to read. So instead of the end character being nothing, what if I do a space? That looks a bit better. After each number, we print a space. What about a tab? Now, remember, I don't want to just do that. Hit tab. I want to do /t to make it a character tab. So now when I try this, the end character being a tab, look at that. Man, that was a nice looking table there. So we've got left to right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's my H. It's going horizontally. On the next row, 2s, 3s, 4s. So all of these are multiples of the first one. So this is one application. We can just do a little grid. If one for loop is one-dimensional, like it's going left to right, it's like a length. A nested for loop would be like a length and a width. It's two-dimensional, hence why we now have a table or a grid or a square or something like that. Okay, so let's do another one. I'm going to steal that. I'm going to take all of that. I'm going to make a word search generator. When I say a word search, it's when you have a grid of all letters and you're looking for a word inside that. So what I'm going to generate here would simply be all of the random letters. I'm not going to actually put words in here. We haven't quite done that yet, but I'm going to do a grid of numbers. Again, we'll do 10 by 10, and if we need to expand that, we certainly can. So if I paste this, let me first give myself a little bit of room here. So I'm going to do print a couple times just between my numbers and my letters. Because I'm doing random letters, I'm going to go back up top here. I'm going to do from random import star, okay, v1 to 11, h1 to 11. So what do we print now? All right, well, let me get rid of this for the time being. And let me remind you of something. When we did the history of programming languages, we talked about ASCII. And we also looked at Unicode a while back, the emoji characters. So if I want to do a random letter, in ASCII, there's one number we asked you to memorize. Capital letter A is... Time for you to think about it. Wait time. 65. Capital letter A is 65. Here's why that number becomes critical. If I say letter equals, and if I want, let's say rand, and then I'm going to do mod 26. Why 26? There's, wow, I'm thinking of C++. I apologize. This is what happens when you do too many languages at once. Random times 26 plus 65. So there's 26 letters in the alphabet. The first one is 65. So from 65 to 90 is letter A to Z. The highest number is 90. 90 minus 65 is 25. 25 plus 1 is 26. So that's where I get that from. If I print this, now it's not going to print the letter yet. We'll get to that. Print the letter, and then, as we did above, if I do a tab in between, and then I back up here and I say print by itself, just so I skip to the next line down, when I run this, I get, yo no, lots of crazy decimals. Why? Well, we didn't put the INT in front of it, so let's put the INT around this. Okay, so that's one little thing we need to fix. We'll do that in a moment. And now look, so it looks identical, except for the fact that now we have random numbers. We need to convert all these into characters. And there's a command that does that. And again, it was back in the video that had the Unicode, the ASCII characters. It is CHR. So right here, if I say I want to convert the number into a character, I do CHR of the letter. Convert the number into an ASCII. Watch what you have now. Now we have this grid of random letters. Pretty neat. Now they are spread out, and because unlike the one above where the numbers are either single digit or double digit, that's kind of what messes up the spacing here. Let me just get rid of the tab and let me say there's no separator from left to right. So check this out. There is a grid of 100 letters, completely random, every time I run it. If I want more, how would I make it expand left to right? Well, again, this is up and down, so the vertical. Right here, horizontal, let's say I want 40, 1 to 40, which of course we put in as 41. This is going to give me a lot more letters, like that. Oh, look, it's the number 2, TWO. I guess I should say it's the word 2. And so, you know, because it's random, you might every now and then find some things in there. But what we would do from here, and we haven't done any of this yet, when we talk about strings, we could print this and then we could fill in, you know, where we'd put actual words. Oh, look, there's the word off. Very exciting. So that is, that will be 2 different applications of the nested for loops. So we're going to be talking about these, you know, again, the rest of this week. We have a couple of practice programs to do. What other things can you do with this? Well, again, I go back to what I was saying earlier about using it for 2-dimensional things. Anything that's a table, anything that's a grid, you would do using a nested for loop, because the first loop represents how many up and down there are, how many rows. The inner loop represents the columns, so vertical and horizontal. So anything that you would want to print out, like a tic-tac-toe grid, a chessboard, battleship, anything like that that you're doing with text, you can use these nested for loops to do. So we'll talk about some of those things in the days to come, because one other thing that we would do with this, we would do something called lists. And we haven't quite done lists yet. But that's another application that we can use with these nested for loops. So keep these things in mind. Not everything's going to be a nested for loop. Again, just as a reminder, single for loops are just single lists. If I say go from 1 to 10, don't use a nested for loop, just do a normal for loop. But anything that will be a grid is going to be using this. And it's not just nesting for loops. You can nest while loops inside for loops inside while loops, if statements. It's just that nested for loops, like a for loop inside of a for loop, they are used for these specific applications. Let me show you one last thing. Let me show you how to find Pythagorean triples, numbers that make a right triangle. 3, 4, 5, 5, 12, 13, things like that. Find all of the Pythagorean triples from, let's keep it relatively small, 1 to 50. Okay. So, let me skip a little bit. I have sides A, B, and C. For A, in the range of 1 to 51. For B, in the range of 1 to 51. For C, in the range of 1 to 51. We have a triple nested for loop. We're going to be running through every one of the numbers. We're going to do 111, 112, 113, 114, 115. Now, a lot of these aren't going to work. But it's like the odometer on your car. It's going to go 119, 1110, all the way up to 1150. After it gets to 50, it's then going to 121, 122, 123. So it's going to roll over. When it gets to the final number, it's going to roll over to the next column. So without doing any kind of Pythagorean triple stuff yet, let me do a print of just what these numbers look like. Because again, you're going to notice that it looks very similar to the odometer on your car, the thing that measures your miles. So look, the left column stays 1. The right column moves the fastest. And again, think about your car odometer, the thing on the far right, tenths of a mile. It goes up, it rolls over to the ones place, then the ones place rolls to the tens place, and so on. And so it's just going to keep going until this gets to 50, then this will be 34. Once it gets to 150, 50, it's going to do 211. It takes a little bit of time. Let me just sit here for a second or two. But you'll see it in action. And there you go. So it rolls over to the next column. Now, of course, these aren't all triples. These are just all of the numbers. So how do we find just the triples? Well, we use the Pythagorean theorem. If a squared plus b squared double equals c squared, then we want to print the numbers. So we put a restriction on it. Now let's try it. There's a lot fewer of these. There we go. Notice it goes much quicker than printing. Printing slows the computer down a great deal, but here are your numbers. And all the combinations are represented in whatever order you have. So 3, 4, 5, also 4, 3, 5. They're both in there. 5, 12, 13, and 12, 5, 13. They're all in there. If we wanted to do no repeats, that's a little bit different. Our program, we'd have to restrict our loops so that each range doesn't start over again. And we can easily do that real fast. We know that if we want A to be the smallest number, then let's start our B loop, instead of at 1, let's start at A. And then for C, we know that the hypotenuse is the biggest number. It's bigger than A and B. So what if we start the C loop at B? Now let's check it out. Now you don't have any duplicates, no combination issues. 3, 4, 5, 5, 12, 13, 6, 8, 10, all of these numbers here make up right triangles. They all fulfill the Pythagorean theorem. So you can nest as many of these as you want. Now just understand, each time you do, you're adding basically an exponential amount more work for the computer. One loop that goes 1 to 10 runs 10 times. If you have a loop that runs 10 times, and you run that loop 10 times, 10 times 10 is 100. It's going to be giving you 100 numbers. Same with both of these. It's going to give you 1 to 10 and then 1 to 40. That's 400 steps. if you add yet another loop to that, well, 1 to 50, and then if we just keep it the way it was, 1 to 50, 1 to 50, 1 to 50, you're looking at 50 to the third power. If you do another loop inside that, you're looking at 50 to the fourth power. So those numbers can get very large very quickly. It's not just a matter of like, oh, it's just one more loop. It's actually, you're taking that times itself many, many times. So just be aware of that. You don't want to nest too many loops because it will slow the computer down a great deal. So that is all for our applications. Hope you learned something. Take care.